Before we begin, there are three words with which we should be familiar. Those words are hazard, risk and control. A hazard is anything that can cause harm. Risk refers to the likelihood of a hazard causing harm. A control is anything we do to reduce the likelihood of a hazard causing harm. These words represent safety concepts that apply to any work activity. An integral part of any safety management plan, an activity hazard analysis is an administrative tool used to control hazards by eliminating or reducing their risks. An activity hazard analysis does this by helping us identify hazards and develop controls. Not only does this keep us safe, but it ensures we are compliant with standards set forth by regulating entities such as the United States Army Corps of Engineers and OSHA. In this toolbox talk we will take a closer look at when an activity hazard analysis should be performed and by whom. We will also examine the 4 questions asked by any activity hazard analysis and how the answers to those questions support our safety mission. Finally, we will review all we learned. An activity hazard analysis should be performed whenever we are doing something new or something familiar in a new way. We should also perform an activity hazard analysis when introducing new products, tools, or equipment to the worksite. Finally, we should perform an activity hazard analysis if new hazards are identified. According to the United States Army Corps of Engineers, the work of conducting an activity hazard analysis should be done by the field crews and personnel performing the work being analyzed. Site safety, quality control, the superintendent, etc., should also assist with the activity hazard analysis process. Ultimately, creating an activity hazard analysis is a group effort which leverages the perspectives, knowledge, and expertise of the entire team to achieve the best possible safety outcomes.
Performing an activity hazard analysis answers 4 basic questions. Those questions are: what am I doing? What are the hazards? How can those hazards be controlled? And how likely are those hazards to cause injury or mishap after control measures are applied? What am I doing? What am I doing is a simple question which unlocks a world of considerations. Considerations like: what methods and procedures will I use to achieve my task? Is my training and experience sufficient for the task at hand? Do I have the right tools and equipment for this work, and are they in good order? How will this work interact with the public and other trades? What are the hazards? When looking at an activity hazard analysis, hazards are identified in the hazards section. This is the section where we consider all the ways injury and mishap can occur. The most common hazard categories are biological, chemical, physical, safety and ergonomic. Let's take a closer look at each of these hazard categories and consider how they may show up in our day-to-day work.
Biological hazards. Biological hazards include things like viruses, bacteria, insects, animals, and plants that can make us ill. Think about your day-to-day work. Does the possibility exist to encounter biological hazards such as rats? What about venomous spiders such as black widows or brown recluses? Chemical hazards. Chemical hazards are hazardous substances that can cause adverse health effects such as skin irritation, respiratory system irritation, and blindness. Have you ever handled PVC cement? Did you know you were handling a hazardous substance? Did you take measures to protect yourself? Safety hazards. Safety hazards create unsafe working conditions. Examples of safety hazards include exposed wires and substandard housekeeping. Have you ever experienced safety hazards such as electric cords in walkways or poorly organized workspaces? Physical hazards. Physical hazards are environmental factors that can harm us without directly touching us. Examples of physical hazards include height and noise. Ask yourself, how often do you work on ladders or enter loud mechanical rooms? Ergonomic hazards. Ergonomic hazards are workplace situations that cause wear and tear on our bodies. Examples of ergonomic hazards include repetition, awkward posture, stationary position, noise, and work stress. Have you ever had to work in an awkward position for a prolonged period? Were you sore afterwards? If you work in an office, have you experienced wrists or neck pain after a day spent in front of your computer?
Once hazards are identified, the next consideration is how to control those hazards. Controlling a hazard means taking a systematic approach to either eliminate or reduce the risk of the hazard causing harm. The hierarchy of control is a hazard management tool used for this purpose. The hierarchy of control is a 5-step approach to eliminating or reducing the risk of hazards causing harm. The 5 steps in the hierarchy of control, from most effective to least, are elimination, substitution, engineering controls, administrative controls, and personal protective equipment. In this section we will examine each of these steps. Before we begin, I want you to think about fighting a bear. Remember this image, it will be important for illustrative purposes as we explore the hierarchy. Elimination. Elimination means removing the hazard altogether. Elimination is the most effective way to avoid injury because the hazard no longer exists. For this reason, elimination should always be the first consideration when looking to control a hazard. This brings us back to our bear. Why would you fight a bear when being rid of it is an option? If eliminating the hazard is not possible, substitution is the next best thing. Substitution means replacing the hazard with something less dangerous. Most people find petting a dog to be more pleasant and far less risky than fighting a bear. Engineering controls. Engineering controls are protections and methods that shield us from a hazard. Examples of engineering controls include using guardrails to prevent falls or using barriers to separate the public from work sites. Personally, I prefer to encounter bears in the zoo. Administrative controls involve changing the way we work when a hazard is present. In our daily lives, this may take the form of amending work practices, procedures, or training. An example of an administrative control would be limiting outdoor work activities when there is an extreme heat advisory. By minimizing exposure to extreme heat, we reduce the chance of heat illness. Which reminds me, I've been told you're less likely to encounter a bear in winter. Personal protective equipment, or PPE, refers to anything we wear to protect us from a hazard. When looking to control hazards, PPE should never be a primary control method. This is because PPE will lessen the severity of an injury, but it won't prevent it. Therefore, we should always look to elimination, substitution, engineering controls and administrative controls before ever relying solely on PPE for our safety. That said, in my limited experience, no one escapes a bear fight unscathed. Just ask this man. So far, we've examined our work, identified hazards associated with that work, and applied our controls. Now, we need to ask ourselves, have those controls effectively eliminated or reduced the risk of hazards resulting in harm? We do this by assigning a risk assessment code, or RAC, using the risk assessment code matrix. Let's take a moment to better understand the risk assessment code matrix.
The risk assessment code matrix is a tool used to categorize risks based on their level of probability and severity of impact. It does this by asking us to consider two things: 1, the likelihood of any given hazard causing harm, and 2, the worst-case scenarios associated with that harm. These considerations are found in the probability and severity sections of the risk assessment code matrix. The probability section of the risk assessment code matrix provides options for describing the likelihood of a controlled hazard causing harm. Looking from left to right, our options in the probability section are frequent, likely, occasional, sometimes, and unlikely. Let's take a closer look at each of these options. Frequent. Frequent hazards are of immediate danger to the health and safety of ourselves and others. Likely. Likely hazards will likely result in harm if the hazards are not controlled, and those harm incidents will persist if the hazard remains uncontrolled. Occasional. With occasional hazards, harm is possible if the hazard is not controlled. But that harm would not be a chronic issue as with likely hazards. Sometimes. Hazards with a probability of sometimes will rarely result in harm, though harm is possible. Unlikely. Unlikely hazards will not result in harm.
Once we identify the probability of a controlled hazard causing harm, we need to consider that harm's severity. This consideration is found in the severity section of the Risk Assessment Code matrix. From top to bottom, our options are catastrophic, critical, marginal, and negligible. Let's look at each of these options in greater detail. Catastrophic. Catastrophic hazards pose imminent and immediate danger of death or permanent disability. Think of the fatal falls, electrocution, struck by and caught in between. Exposure to any of these hazards could easily result in death or permanent disability. Critical. Critical hazards could result in a permanent partial disability like losing an eye or a temporary total disability such as being in a full body cast. Marginal. Marginal hazards may lead to a brief hospitalization or a reversible illness such as a skin rash. Negligible. Negligible hazards prompt little more than a trip to the first aid kit for a band-aid. The intersection of probability and severity provides our risk assessment code. The code, which is found on the far right section of our activity hazard analysis, identifies the level of risk that remains after the hazard is controlled.
Statistically, creating an activity hazard analysis and adhering to its identified controls is the most effective means of avoiding workplace injury. This is because 80% of workplace accidents are caused by human error. An activity hazard analysis aids in reducing human error by focusing our attention on the task at hand. An activity hazard analysis does this by requiring we answer 4 simple questions before approaching our work. Those questions are: what am I doing? What are the hazards? How can the hazards be controlled? And what is the likelihood of harm resulting from a controlled hazard, and how severe would that harm be? Our first goal, whenever we perform an activity hazard analysis, should be to avoid injury by eliminating the hazard. If eliminating the hazard is not possible, we should then work through our hierarchy of control to find the most effective means of reducing the likelihood of that hazard causing an injury. As a tool, an activity hazard analysis is most powerful when created and implemented by you, the personnel performing and/or overseeing the work being analyzed. So, remember to review your activity hazard analyses daily. And for every task. If there are unique challenges or new hazards not captured in a particular activity hazard analysis, revise the document to reflect those realities. Ultimately, an activity hazard analysis is a living document only as viable as our efforts to keep it relevant to the job at hand. Therefore, it is important we constantly assess our activity hazard analyses to ensure they remain effective tools for managing ourselves and our work.
1. An activity hazard analysis focuses our attention on the relationship between ourselves, the task at hand, and the work environment. 2. Creating an activity hazard analysis is a group effort led by the personnel performing the work. 3. An activity hazard analysis should be performed whenever doing something new or something familiar in a new way. Additionally, an activity hazard analysis should be performed when introducing new products, tools, or equipment to the worksite. Finally, an activity hazard analysis should be performed when new hazards are identified. 4. Eliminating a hazard is the most effective means of hazard control. Relying solely on PPE is the least effective. 5. The activity hazard analysis for any given task should be reviewed with site personnel prior to performing that task. Remember, 80% of accidents are caused by human error. Therefore, using the activity hazard analysis to manage ourselves, the human factor, is essential to our safety mission.